Hello, so today we're taking a look at Concept 7, Graphing Linear Equations. Today we're going to specifically be looking at graphing things in standard form, ax plus by equals c, and then graphing things that are, graphing linear equations that are in slope-intercept form, y equals mx plus b. So hopefully these definitions here should be a little bit of review for you. They're things that we have done in prior concepts. So in the textbook it says, the local hiking club is finalizing its plans for a trip to the Rocky Mountains in Canada. The hikers are discussing the food they will have to carry with them to complete their climb up the mountains. The group decides to set out with 84 pounds of food and figures that together the hikers will eat 11 pounds each day. To make sure they will have enough food, the members of the club want to show that their food supply what it looks like at the end of each day, as well as at the end of their trip. What can they do to create a visual picture of their food supply? So eventually we're going to be taking a look at this problem later on. So graphing linear equations, just kind of introducing the idea in the textbook. It says when graphing a straight line, you need 2 points to be plotted. And those 2 points can be the x and y intercepts. And so when you have something in standard form, ax plus by equals c, kind of a shortcut way of finding your x and y intercepts is just looking at those coefficients or those numbers in front of the x and y variables and then that constant c that they're equal to. And I have that written out here as well, the shortcut for x-intercept and y-intercept. Now we have found x and y intercepts in the past, going through that process of like plugging 0 in for y and solving for x, or plugging 0 in for x and solving for y if we're looking for the y-intercept. And this is just kind of a shortcut method of doing the exact same thing. Okay, so if we look at the problem they give us to kind of start this off, we have the equation 3x plus 5y equals 15. So to find our x-intercept, and actually I'm going to back this up a little bit. So 3x plus 5y equals 15. That means A is 3, B is 5, and C is 15. So applying the shortcut that we have here, and again, use the shortcut if you like it. If you don't like it, then go back to what we did in the prior concept of going through that two-step process of plugging 0 in and then solving, because that's going to get you the same results. All right, so using kind of the shortcut of x-intercept being c divided by a. Well, c is 15 divided by a, which is 3, is telling me that we're going to cross the x-axis at 5. Then finding the y-intercept using this shortcut, which is c, a value of 15, divided by b, a value of 5, gives me 3. So I know that this is going to cross the y-axis at 3. Now what I can do is I can take this information and I can graph a Cartesian grid. And I'm just labeling. All right. I can plot points at 3 on the y-axis, 5 on the x-axis, and I can connect them in as straight of a line as I can draw and get my graph. So we can use that bit of a shortcut to then graph these when they're in standard form. And that's the first thing that this goes through. Next, it says, and you can see the graph there. Next, it says, okay, well, what if something is in slope-intercept form? So if we have something in slope-intercept form, and the problem they give in the textbook is y equals 2/3 x plus 1, we can use our knowledge of slope and y-intercept to graph this. So y equals 2/3 x plus 1, well, our slope, according to this problem, our value of m is 2/3, meaning the amount we rise is 2 and the amount we run is a positive 3 to get from one point to the next. The other piece of information I'm told by the way this equation is written is my y-intercept. I'm told that the y-intercept is a value of positive 1. So I can draw my Cartesian grid. Again, I'm just listing my points. I can start, so when you're going to use this slope-intercept form, you do have to start with your y-intercept. So you need to make note, when graphing, start with your y-intercept. Then apply slope. So I'm going to start with the fact that this graph crosses the y-axis at 1. I have a y-intercept of 1. Now I'm going to apply my slope. It says to rise 2 units and run 3 units, both of which are positive. So I'm going to go up 2 units, and then I'm going to run 3 units to get to my new point. And then I'm going to connect those with as straight of a line as I can, and there's my graph. So again, I applied slope by going up 2 units and then going to the right 3 units because those are my values of rise over run. And you can see that here. So let's take a look at example 1. And example 1 is bringing us back to that hiking problem. So it says earlier, given a problem about a hiking club and food, the hikers need to keep track of the 84 pounds of food they're carrying. If they eat 11 pounds of food a day, how can they create a visual display of the food they have left at the end of each day? So the information, they're having y equal the pounds of food left at the end of each day. All right. They're saying M is the pound of food eaten each day. It says X is the number of days. And B is the number of pounds of food being carried. Now, it says we get the equation when substituting our numbers in of a negative 11d plus 84. And it says graph the equation on the Cartesian grid. I don't know why the image didn't save on this PDF, but it's not here, but that's okay. We're going to go through this ourselves. Now, I know that we have this variable d instead of x. Okay, know that it says d instead of x, but it's really referring to the same thing. Does not make a difference, okay? So if you're like, I really don't like that that's written with a variable of d instead of x like we normally write things, then that's fine. Rewrite it. Negative 11x plus 84. Now, to begin graphing this, I need to identify my slope. Our slope has been identified as negative 11. Normally, when we have slope, we have it written as rise over run, and we don't have that here. But know that you can write any number as a fraction as long as you write it over 1. So my slope can really be rewritten as negative 11 over 1. So then that's telling me my rise is a negative 11 and my run is a positive 1. My y-intercept, according to this equation, is 84, meaning I'm going to cross the y-axis at a positive 84. So I'm going to use this information to graph my this negative 11x plus 84. So I need to draw my grid off to the side here. Now I'm drawing a really big positive y-axis because I have to make it to 84. So I'm not going to be able to go by ones, but I might be able to fit going by like 5s or 10s. And I can almost make it if I give myself a little bit more room here. All right. And then my x-axis, so I went by 5s on my y-axis. So every other tick mark is 10. And then I'm going to go by 1s on the x-axis. So I crossed the y-axis at 84. So I'm going to plot that point as best as I can. I know that this is going to be an estimate because I'm going by 5s, and to see that single value of 1 is going to be kind of hard. All right, so 84 is approximately there. Now my slope is negative 11 over 1. Again, this is going to be a little bit hard to graph on my scale, but let's do our best estimate. So we're going to go down 11 units and to the right 1 unit. So to my very best ability, I'm going to go down to approximately negative 74, and then I'm going to go to the right 1 unit, and I'm going to get approximately that point. Now, if you feel like these points are a little bit too close for you to connect them and get a very accurate graph, you could keep going and keep going down another 11 units and to the right 1 until you feel like you have enough points, and then connecting them with about a straight line.